Hello dear students, in this video we will be learning something very interesting. So before we start with today's topic, do subscribe to our channel and stay updated of our new videos. So today's topic is universal law of gravitation. Before getting into this topic, have a look onto this clip. If Newton would have seen this, his reaction would be like, It was a pleasant day, and Newton was just spending some time under the shades of a tree, and all of a sudden, an apple fell on his head. He just wondered how an apple is falling down. He strived day in and day out. He did a complete research and finally presented his discovery in an assembly of Royal Society. And finally, he proposed a law, and that is the universal law of gravitation. Newton's name in the Gravity Hall of Fame is not due to his discovery of gravity, but rather due to his discovery that gravitation is universal. Now, the question is, what is this universal law of gravitation? Is it something like what we have seen in our first slide? Yes, it is the same as if we take an example, but let me say you, the first law of cartoon is completely false. Now, what is wrong in that law? Now let's study that in our next slide. Consider two objects A and B having masses m1 and m2. Let the distance between A and B be d. The force acting on A is F1 and the force acting on B is F2. Consider Newton's famous equation, that is F net is equal to m into A. Newton knew that the force that caused the apple's acceleration must be dependent upon the mass of the apple, that is m1. And since the force acting to cause the apple's downward acceleration also causes the Earth's upward acceleration, which is nothing but gravity. We can take which is nothing but gravity, and it states in the Newton's third law, that is, for every action there is opposite and equal reaction. Therefore, the force also depends upon the mass of the Earth. So, for Newton, the force of gravity acting between the Earth and any other object is directly proportional to the masses of the object and inversely proportional to the square of distance that separates the centers of the Earth and the object. Therefore, universal law of gravitation states that the force of gravity acting between the objects is directly proportional to mass of both the objects, and inversely proportional to the square of distance between them. State F is nothing but the force between both the objects. G is nothing but the gravitational constant G is nothing but the gravitational constant, which is equal to 6.67 into 10 power minus 11 Newton meter square per kg square, whereas M1 and M2 are the masses of objects and d is nothing but the distance. Since we know the equation, let's move to our next slide and solve a question, a numerical. So we have a question that is, determine the force of gravitational attraction between the Earth having mass 5.98 into 10 power 24 kg and a 70 kg Salman Khan. If the actor is in an airplane at 40,000 feet above the Earth's surface, this would place the student a distance of 6.39 into 10 power 6 meter from the Earth's center. Now let's understand what this question states. Now, what's given in the question, let's write down that first. Given mass of Earth, which is M1, mass of Earth, which is M1, that is 5.98 into 10 power 24 kg. We got the mass of Earth. Now the mass of actor, that is Salman Khan. Let's take it as M2, which is 70 kg. If the actor is in an airplane at 40,000 feet, just ignore this. There's no height component in our formula. So next we got M1 and M2. Gravitational constant, we know that is 6.67 into 10 power minus 11 Newton meter square per kg square, right? And the distance d, that is given as 6.39 into 10 power 6 meter. So we'll change the question a little bit and have a look onto this video. Imagine Salman Khan is on the top of a temple, okay, and having a weight 70 kg and Earth mass is 5.9 into 10 power 24 kg. Just have a look onto this video. Right? I don't know how ugly Salman Khan is here. Anyways, let's move on to solving this question. Okay? So now we have got all the given content here, that is we have got M1, M2, gravitational constant g, and finally the distance there. So now let's put this in this formula. So F is equal to gravitational constant d, that is 6.67 into 10 power minus 11. Then we have mass M1, that is 5.98 into 10 power 24 into, I'll do one thing, I'll just clear the screen and write once again. Okay, so now G is 6.67 into 10 power minus 11. Okay, then the mass M1 is nothing but 5.98 into 10 power 24, and M2 we have, that is 70 kg divided by d square. Distance is 6.39 into 10 power 6. Now when we calculate the entire thing, the answer what we get is, I'll give you 5 seconds of time. Try out solving this. Did you get it? Okay. Let me tell you, if you are in a state board, you just need to write it in this form and all other work is done by a calculator. If you are a CBSE student, Of course, you need to solve this entire thing. Now, try solving it. The answer is nothing but 686 Newton. In the next slide, I have a surprise for you all, which is nothing but a small homework, which is nothing but a DIY, a special series from now on. Every topic what we discuss will be having a numerical, and at the end we will be giving you a DIY, which is nothing but do it yourself questions. So here are a few questions, two questions, that is a football player of 100 kg and physics student of 70 kg. Try solving these questions. Leave the answers in the comment section below. Hope you enjoyed today's video. Share with all of your friends and stay tuned.
Yeah.